Welcome to the DIY Honda Garage channel. This presentation addresses the DTC codes P0202 and P0203, indicating a malfunction in the number 2 and number 3 cylinder injector circuits of the Honda Civic from 2016 to 2021. Understanding these codes is crucial for diagnosing issues related to the fuel injection system, which is vital for engine performance. These codes can lead to poor fuel efficiency, increased emissions, and potentially stalling or failure to start if the problem is severe. Each injector circuit is responsible for delivering fuel to its respective cylinder at the correct timing, ensuring optimal combustion. When malfunctions occur in these circuits, it can affect engine idle, acceleration, and overall performance. The subsequent slides will detail the error description, causes, symptoms, and step-by-step troubleshooting processes to address these DTC codes effectively. DTC P0202 refers to a malfunction in the injector circuit for the number 2 cylinder, while DTC P0203 indicates a similar issue for the number 3 cylinder injector circuit. The fuel injectors are responsible for precisely delivering fuel into the combustion chamber, which is essential for efficient power generation. The Powertrain Control Module, PCM, regulates the injector operation, timing, and fuel amount based on many factors like engine load and speed. The location of these injectors is within the engine cylinder head, directly connected to the fuel rail. When the PCM detects an issue, such as an open or shorted circuit in these injector lines, it triggers the corresponding DTC. Understanding these components and their interactions is vital for effective troubleshooting. Several potential causes can contribute to the DTC P0202 and P0203, with each one requiring thorough investigation. First, faulty fuel injectors may prevent proper operation, leading to misfiring or fuel delivery issues. Open or shorted wiring can disrupt electrical signals between the PCM and the injectors, resulting in circuit malfunctions. A defective injector relay may also fail to supply adequate power to the injectors. Ultimately, a faulty PCM might misinterpret data or fail to operate the injectors correctly. Identifying the root cause is essential in ensuring effective repairs and restoration of system functionality. The symptoms associated with DTC P0202 and P0203 can significantly affect overall vehicle performance. An engine misfire is commonly reported, where the combustion process is inconsistent, leading to a power loss. Rough idle conditions arise due to improper fuel delivery to the affected cylinders, which can also cause vibrations and noise during operation. Additionally, drivers may notice poor acceleration as the vehicle struggles to receive sufficient fuel to maintain power. Lastly, increased emissions can occur as incomplete combustion processes lead to unburned fuel passing through the exhaust system. Recognizing these symptoms is crucial for prompt troubleshooting and resolution. For the initial troubleshooting step, first turn the vehicle to the on mode without starting the engine. Utilize the Honda Diagnostic System, HDS, to clear the stored DTCs, which resets the system and allows for accurate assessment of active issues. After clearing, start the engine. If the engine does not start, crank it for 20 seconds. This process can help determine if the problem persists or if it was a temporary glitch. Following this, check for any pending or confirmed diagnostic trouble codes with the HDS. This first step is integral to identifying whether the malfunction is ongoing or intermittent. After attempting to start the engine, assess whether it successfully starts up. If the engine does start, this indicates the potential for error codes related to intermittent issues. In this case, proceed to step 11 of the troubleshooting guide. However, if the engine does not start, further investigation is required, and you should move to step 3 for relay checks. The outcomes of this step will lead to targeted diagnostics, helping to either confirm or rule out certain components in the injector circuit malfunction. For this step, ensure the vehicle is turned off and in the lock mode. Next, remove the injector relay from its socket to assess its functionality. Testing the injector relay is crucial as it directly affects whether power is delivered to the injectors. If the relay tests as functional, the issue might lie elsewhere in the circuit, and you should advance to step 4 of the process. If the relay is found to be faulty, replacing it should rectify the problem, leading to an operational injector circuit. In this step, with the vehicle still off and the injector relay disconnected, measure the voltage between specified test points. Test point 1 is located in the injector relay 4P socket number 7, while test point 2 is connected to a solid body ground. You are looking for battery voltage, which indicates that the +B IGP wire is intact. If voltage is present, that wire is functioning correctly, and you should proceed to the next step. Conversely, if there is no power, you need to continue to step 5 for fuse inspection. Now you need to check fuse number A7, rated for 15A, located within the underhood fuse/relay box. This particular fuse is critical for ensuring the proper operation of the +B IGP wire. If the fuse is functional, you must search for any opens in the existing wire running between the A7 fuse and the injector relay. If the fuse is blown, repair any shorts in that wire and replace the fuse to restore functionality. This involves measuring the voltage between the injector relay 4P socket number 3 and body ground while keeping the vehicle in off mode and the injector relay disconnected. If you find battery voltage, this indicates that the +B INJ wire is working fine, and you can then move on to step 8. If there is no voltage, it leads to possible wire issues that require further diagnostics in step 7. For this retest, check fuse number A10, also rated at 15A, located in the same underhood fuse relay box. Determining the status of this fuse is as important as checking the first fuse. If the fuse is intact, again, look for possible opens in the +B INJ wire. If found to be blown, repair shorts in the wire. Replace the A10 fuse and ensure the system is restored properly. For this, while in on mode and the injector relay disconnected, assess the voltage between two specific points in the injector relay 4P socket. These points are 7 and 8 within the socket. Securing battery voltage here indicates that the electrical flow through the FI main RLY CL line is intact, consequently allowing you to proceed to the next prescribed step. However, if there is no voltage, you need to investigate possible open wire connections in the FI main RLY CL line, as instructed in step 9. In this step, ensure the vehicle remains in the off mode while disconnecting the relevant PCM connector. Here, you will perform continuity checks between the injector relay socket and pin number 5 in the PCM connector A. Confirming continuity indicates that the FI main RLYCL wire is functioning properly. If the tests indicate no continuity, it suggests an issue within that wire, requiring repairs to ensure uninterrupted power transmission. With the vehicle in off mode, connect specified terminals in the injector relay socket and perform a voltage measurement using PCM connector pins. This checks for correct function of the INJ-RLY out wire. Finding battery voltage confirms effective electrical connectivity. If not, it indicates potential issues that require a detailed inspection for open circuits between these connections. Returning to the initial DTC assessment will help narrow down which steps to take following your previous troubleshooting. If DTC P0202 shows up again, it is a signal to advance to step 12 for further diagnostics. If not, then the issues may not relate specifically to these injectors, allowing exploration into other components or systems that may be contributing to operational problems. Here, continuity testing needs to occur between specific PCM pins, while ensuring the injector relay is reinstalled. This step aims to validate connections within the INJH2 and INJL2 wires. Confirming wire integrity will allow you to indicate a functioning circuit. If continuity does not exist, it identifies the need for wire repairs in the respective lines connecting to the injectors. For this check, you must disconnect the number 2 injector 2P connector to facilitate testing of the INJH2 wire. Conduct a continuity assessment to verify the wiring integrity between the injector and the PCM pin. If continuity is confirmed operational, proceed to step 14. Conversely, any issues here necessitate focused repairs to address the identified open circuit. Continue investigations by assessing continuity for the INJL2 wire with the relevant PCM connector disconnected from the system. Measurement between the number 2 injector connector's specified terminals allows confirmation of circuit functionality. If everything confirms operational status, you may replace the existing number 2 injector, as it could be at fault for the malfunction. Troubleshooting elements necessitate that you also understand any possible miscommunications occurring within this system. In this step, the objective is to assess the INJH2 line for any shorts to power while considering that the injector connector is still detached. Proper measurements taken will tell you whether the wiring functions correctly. Affirmative voltage readings prompt further corrective actions for shorts. It's important to ensure a thorough examination of wire routing to prevent future circuit failures, with focus on the INJL2 line. Again, measure voltage between specified points while keeping other components disconnected. This assessment looks for any shorts to power similar to previous checks. The information gathered guides further troubleshooting steps, ensuring the focus remains on diagnosing the precise source of the malfunction. At this stage, measure continuity for the INJH2 line while having the vehicle in an off position. This ensures no power is flowing while assessing for potential shorts to ground. Acknowledging any continuity may indicate the line is functioning as intended. Should faults be identified, consider repairs based on the testing results, directing focus back to the integrity of wiring along the connector routes. Similar to the previous steps, this examination requires continuity checks for the INJL2 wire with the system in an off position. Testing will provide insight into the wiring system integrity across multiple connection points. Should the line be functional, it indicates proper electrical flow. Otherwise, repairs to the line will be necessary to restore complete functionality and avoid ongoing faults. For short pending diagnostics, this involves disconnecting the number 3 injector connector and performing a continuity assessment for the INJH3 wire. Establishing a complete circuit here affirms no shorts exist, allowing you to determine the next appropriate steps based on the results. Connectivity indicating faults will dictate the need for repairs along that line to prevent future errors. The final testing measure for both injector lines, INJH3 and INJL3, focuses on confirming functionality before concluding diagnostics. The continuity test provides confirmation that these wires are intact, setting the stage for final assessments. If the wiring is confirmed as operational, the next steps lie in evaluating whether the PCM needs replacing or not. Be diligent in ensuring that all connections throughout this process maintain integrity for future operation. Following the completion of all necessary repairs, clear the diagnostic trouble codes using the Honda Diagnostic System, HDS, to reset the vehicle's status. It's crucial to perform a test drive to ensure the repairs have resolved the issues successfully. Observe for any signs of repeated DTC occurrences or abnormal vehicle behavior during the drive. This verification step is essential to confirm the successful restoration of normal function and ensure that no further intervention is immediately required. For preventive maintenance, it's essential to maintain a regular inspection of wiring related to the fuel injectors. Check for integrity, especially after notable events like engine replacement or repair work in adjacent systems. Make it a routine to inspect injector functionality, ensuring they operate correctly under all conditions. Proactively monitoring for any new DTCs can facilitate early detection of problems before they escalate to significant malfunctions. Continuous vigilance helps in extending the longevity of the injector circuit and overall engine performance. In conclusion, understanding the implications of DTC P0202 and P0203 is critical for effective vehicle maintenance. Adhering to thorough troubleshooting steps not only identifies faults accurately, but also guides towards efficient repairs. Preventive measures nurture the stability and longevity of the fuel injection system. Recognizing symptoms early on and maintaining an informed approach can significantly reduce potential operational failures. Ensuring that both mechanical and electrical systems are regularly maintained will promote sustained vehicle performance, ultimately enhancing the driving experience. Please like and subscribe to the channel. See you next time.